Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. A gasoline engine operates by repeating the following cycles. The intake stroke, where the piston moves down to draw in a mixture of air and gasoline. The compression stroke, where the piston rises to compress the mixture. The combustion stroke, where the spark plug ignites the mixture, causing combustion that forces the piston down. And the exhaust stroke, where the piston rises again to expel the burnt gases. For this reason, this type of engine is called a four-stroke engine. First, we will look at the mechanical parts. The piston and connecting rod are connected by inserting a piston pin, allowing the connecting rod to pivot relative to the piston. The crankshaft is supported by the engine block via the crank journals, and rotates around the central axis of the crank journals. The connecting rod is attached to the crank pin. The sliding motion of the piston pin at the top of the connecting rod, and the crank pin at the bottom, converts the piston's up and down movement into the rotational motion of the crankshaft. The intake and exhaust valves, which control the engine's intake and exhaust, are operated by the camshaft. The valves are constantly pushed up by valve springs, sealing the combustion chamber. When the cam lobe pushes the valve down, the passage to the combustion chamber opens, allowing the air-fuel mixture or exhaust gases to flow. The camshafts are driven to rotate from the crankshaft by a timing chain, or timing belt. The gear ratio between the camshaft sprocket and the crankshaft sprocket is 2:1, resulting in the camshaft rotating at half the speed of the crankshaft. Camshaft and valvetrain systems are classified into OHV, OHC, DOHC, based on camshaft position and number. The distance that the piston moves up and down is called stroke. The inner diameter of the cylinder is called bore. An engine with a stroke shorter than the bore is called a short stroke type, while an engine with a stroke longer than the bore is called a long stroke type. Generally, short stroke engines are considered high engine speed, high power engines, while long stroke engines are more suited for high efficiency applications. For reference, the engine of the Ferrari 296 GTB is a short-stroke engine with a bore of 88 mm and a stroke of 82 mm. The engine of the Mercedes-Benz E-Class is a long-stroke engine with a bore of 83 mm and a stroke of 92.3 mm. There are various types of engines depending on the number of cylinders and the cylinder layout. In modern passenger cars, the commonly used configurations are parallel 2-cylinder, inline 3-cylinder, inline 4-cylinder, inline 6-cylinder, V6, and V8 engines. Since burning gasoline generates a large amount of heat, a cooling system is necessary. Additionally, as metal parts inside the engine rub against each other at high speed, a lubrication system is also needed to prevent wear and overheating. Videos about these topics have also been uploaded. If you are interested, please take a look. The links are in the description. Fuel is injected into the air drawn into the engine through a fuel injector, positioned in the intake manifold. The amount of fuel injected is calculated by the engine control unit based on various parameters, but the most basic injection amount is determined by the engine speed and the amount of air the engine takes in. The engine speed is detected by a rotation sensor that monitors the rotation of a pulse rotor installed at the front end of the crankshaft, and the signal is sent to the engine control unit. There are various types of rotation sensors, such as pickup coil sensors, Hall effect sensors, and magnetoresistive sensors. The intake air amount is detected by an air mass sensor installed in the intake manifold. Today, two types of air mass sensors are used. The Kármán vortex sensor, which counts the vortices created by the flowing air, and the hot wire sensor, which detects the temperature drop caused by the flowing air. When the spark plug sparks, the compressed air-fuel mixture ignites. The ignition coil steps up the 12 volts from the vehicle's electrical system to 10,000 to 20,000 volts, creating a spark at the spark plug electrodes. The basic ignition timing is calculated by the engine control unit based on the engine speed and throttle valve opening. The engine speed is detected by the crankshaft rotation sensor, and the throttle valve opening is detected by the throttle valve position sensor installed on the throttle valve motor. The engine control unit detects the amount the driver depresses the accelerator pedal using the accelerator pedal sensor, and calculates the appropriate throttle valve opening and drives the throttle valve motor to open and close the throttle valve. The throttle valve position sensor detects the actual opening degree of the throttle valve that driven by the control unit. If you would like to learn more about electronic engine control systems, please watch the video, How Electronic Engine Control Systems Work. The link is in the description. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.